It's a great day, grade 10s, as we continue this journey of trigonometry. So, trigonometry, what we've been working on for the last couple lessons, we have focused on the sine rule. Well, first of all, we have to make sure that we know that we have a right angle triangle. Now, the steps that we are starting to hopefully get tired of, which means they're becoming ingrained in your brain. Reference angle, essential. Second thing is we need to label the sides based on the reference angle. We have the side opposite, we have the side adjacent, and we have the hypotenuse. After that, we have been writing out the appropriate trig ratio, which for us has been sine, which was sine of our reference angle, which always needs to be included, is always comparing the opposite side over the hypotenuse. Then from there, once we have information in our trig ratio, we've been solving. And here's where we've had to now start to make some decisions, because there's two things to do to solve. If we're solving for a side, our last step is to cross multiply. Whereas if we're solving for an angle, our last step is to inverse sine the decimal or fraction value. But reference angle, label the sides, the trig ratio, those steps don't change. It's just at step 4 solving where we have to start thinking. Well, now we're getting into this lesson, the cosine ratio. And we'll look at the notes in a sec, but what's great about the cosine ratio is the process isn't going to change. We still need to identify the reference angle that we're going to use. We still label the sides opposite, hypotenuse, and adjacent. Here now is where the first change is. We still want the trig ratio, but with cosine, we still have cosine of the reference angle, but instead of opposite and hypotenuse, which sine is, cosine compares the adjacent side to the hypotenuse. So now we have different sides we're going to work with. Adjacent over hypotenuse, but it's still the same step. And solving, well, solving is going to be the same. If we're using cosine and we want to solve for a side, we're still going to cross multiply. If we're using cosine to find an angle, we're still going to do inverse trig, but this time we'll do inverse of cosine. So steps and process don't change. It's just the ratio that we work with. So let's turn to the notes and let's see what we got. And again, we're probably going to have to review what I just talked about, but that's okay. So this is page 19. The cosine ratio is the second of 3 trig ratios. Got that. It's almost identical to the sine ratio, and I just walked through those steps. Except now we're using different sides in our trig ratio. We're using adjacent and hypotenuse instead of opposite and hypotenuse, which is what sine is. And we're going to push the cosine button instead of the sine button. And that's the one that kids, I find students make the biggest mistakes, is they get so used to using the sine button, they're kind of, I'm not getting the right answer, Mr. McDonald. I don't know what I'm doing wrong. You're pushing the wrong button. Make sure you know which trig ratio you're using so you use the appropriate sides and the appropriate button. And as always, please make sure your calculator is in degree mode. That's key. All right, here we go. Let's take a look really quick to make sure we can do things that are appropriate. So in this case, we want to find the cosine value. When we're cross multiplying, sometimes we have to input cosine 33. Don't do anything special. In this case, you just do what it says. Cosine 33, cosine 67, cosine 44. So if I pull my calculator up, I clear it. I'm going to quickly go to mode. Look at that. I see the degree is highlighted. Perfect. That's what we want. So now I want cosine of 33. Get in the habit. Make sure you close that bracket. And we want 4 decimal places. 0.8387. If you forget to round, this technically decimal 838 and the 7 beside the 6 tells us to round up. That, if we forget to round and use this, 4 decimal places will still get us the right answer. That's what's nice about going 4 decimal places. Second one was cosine 67. So cosine 67, just like it says, I don't have to do anything different, 0.3907. And the last one was cosine 44. So cosine 44, close your bracket, 0.7193. So nothing special with these 4 decimal places, because all it tells you to do is cosine that degree. Now, we're not going to work with sides and angles totally separate today. After the sine work, we're going to work with cosine, both sines and angles in this lesson. So remember, the second bit to using the calculator is when we're finding the angle measure, we need to second function or inverse cosine. And degrees tend to be to the whole degree. So this first bit, cosine x equals 0.9633, we're finding the reference angle, because that's how we write it. Cosine of theta, your reference angle. So we want the reference angle, so we need to second cosine, inverse cosine, decimal 9633. So let's make sure we're doing second cosine, and there's our little -1, which tells us we're inversing, which is perfect for an angle, and we want 0.9633. Close your bracket, and what do we get? 15.57 or 15.5, which is a 16-degree angle to the nearest degree. The next one is cosine x, decimal 8364. So again, cosine, x, first one worked out to be 16 degrees, but this time we want the reference angle. And to find an angle, we second function or inverse the decimal value. So go back to our calculator, second function cosine, show that it's the inverse, decimal 8364, close your bracket, 33.2 is a 33-degree angle. And there we go. And the last one, inverse cosine, because we're finding the angle, decimal 3254 is a 71-degree angle. Just remember, when we set up our ratios, it's possible, usually it's going to start as a fraction. If you want to convert it to the decimal first, that's okay. We can take that 25 divided by 83 and work with the decimal. If we were to do that, we'd be working with cosine x equals 0.3012. So it doesn't matter if I punch it in as the fraction or I punch it in as the decimal. Both cases, though, we're finding the angle, so we need to second function. So, again, second function cosine, 25 divided by 83. 25 divided by 83 as a fraction, we get a 72.4 or 72-degree angle. If we're using the decimal equivalent of it, decimal 3012. Close our bracket. What do we get? We still get a 72-degree angle. So whether you use the fraction value or the decimal value, we're still inversing because we're finding an angle size, which is essential. So, review of the calculator work. Well, if we move on, these two boxes at the bottom, they don't tell us anything new. If we want to solve for a side length, choose your reference angle, step 1. Label the sides, step 2. Substitute appropriate information into your cosine function this time. So we would have cosine theta equals adjacent over hypotenuse because it's now cosine. But that third step is still substitute into our formula. Then, last step, solve. Solving for a side is cross multiplying. Nothing has changed in terms of process compared to sine. If I want to solve for an angle measure, still those same steps. Reference angle, step 1. Label your sides, step 2. Substitute into your, cosine function. Again, there it is. We're going to plug 2 bits of information in. But because now with solving, we're finding an angle, we're going to convert the fraction to a decimal or work in fraction form, whichever one works best for you. And inverse cosine to calculate. Same steps as sine, just different sides and a different button. So let's take a look at a couple of these. First example says to solve for the unknown side in the following right triangle. So we're finding the unknown side, side x. First step, reference angle. Second step, label the sides. Third step, substitute into your trig ratio, which now we're working with cosine, adjacent over hypotenuse. And then we solve. Well, solve is 2 choices like we've reviewed. Cross multiply for a side, inverse trig for an angle. So in this particular one, we're finding a side. We should know that we're going to finish with cross multiplying. So reference angle. Use what you know to find what you don't. So we're going to use reference angle 16. Label your sides. Opposite the reference angle is side opposite. Opposite the 90 is always your hypotenuse. What does that leave us with? That leaves us with the adjacent, the side attached to or adjacent to the reference angle but isn't the hypotenuse. So now if I were to look at this, I'm trying to find adjacent, so I need to use it. We have the hypotenuse, so we should use it. In this case, the opposite, we don't know it. It doesn't tell us what it is. It's also not what we're trying to find. So in this case, opposite doesn't do anything for us. So we know with adjacent and hypotenuse, cosine of our reference angle is adjacent, which is unknown, over the hypotenuse, which is 23. How do we find and solve for a side length? Set it over 1 and cross multiply. So we now to cross multiply this time, cosine 16 times 23 divided by that extra piece will give us x. Make sure this isn't just 16, that's a cosine 16 times the 23. So let's pull up our calculator. Cosine 16, bracket that, times 23 equals, divide by 1, which doesn't really do anything. We have a 22.1 length for our unknown adjacent side. So x is 22.1 for a length. Doesn't tell us what it is, units, but rounded to the 10th. There's your steps. Same steps as sine, just different buttons, different sides. So, solve for the unknown side in the following right triangle. Here we go again. Reference angle. Use what you know to find what you don't. Across, opposite, the reference angle is side opposite. Opposite, the 90 is the hypotenuse. Leaves us with adjacent. That's the routine I've always used to find and label the sides. In that order, opposite, hypotenuse, adjacent. It just works for me. You maybe use a different process. There's no wrong way to do it necessarily. Reference angle, labeled our sides. Let's look at what we have. We want the hypotenuse, so we have to use it. We know the adjacent, so we're going to use it. The opposite doesn't tell us anything, isn't being asked for, it doesn't do anything for us. So again, adjacent hypotenuse, there's our cosine trig ratio. Cosine of our reference angle, adjacent 68 over hypotenuse, which is our unknown. Find a side length, same as always, set it over 1 and cross multiply. Careful with your cross multiplying here. What do we know to cross multiply? 68 times 1. Divide by the extra piece, which is a cosine 63, not just a 63. Multiply what's across, divide by the extra piece, and that will equal our x, which in this case is our hypotenuse. So 68 times 1 divided by cos 63. 68 times 1 divided by cosine 63, close your bracket, hit enter, and we get 149.78. 8 tells us to round up, so we get 149.8 for a length. So x is 149.8 for the length of our hypotenuse. Cosine, same steps as sine. Can't stress that enough. So now, calculate the unknown angle in the following right triangles. Round to the nearest degree. So now we're finding an angle. It's still reference angle. Label the sides. Write your trig ratio, which again today, cosine of our reference angle, adjacent over hypotenuse, and solve. Same steps over and over, but because now we're finding an angle, our solve will be the inverse trig, which for this lesson will be cosine. So our reference angle, our first step, this time, because we're finding an angle, we want to use that angle as our reference angle. Whatever angle you want is your reference angle. Label the sides. Opposite, the reference angle is side opposite. Opposite, the 90 is your hypotenuse. Leaves you with adjacent. Adjacent to the reference angle, but isn't the hypotenuse. Labeling's done. Trig ratio. Well, let's analyze real quick. If I want to find an unknown angle, I have the adjacent. That's a good thing. I have the hypotenuse. That's useful. The opposite, it's not asking for it, and we don't know it. It's not helpful. But that makes sense because hypotenuse and adjacent is cosine. Adjacent 8 over hypotenuse 14. And here is the situation now, after we substitute it in, to solve, find that unknown angle. We're given the fraction. Two things you could do here. We can work with just the fraction or turn it into the decimal. 8 divided by 14, 0.5714, and then we get the angle. Doesn't matter which process you use here. In this case, second function cosine, because we're finding the angle. One possibility, 8 divided by 14, or the fraction form. What does it give us? A 55-degree angle. If I second cosine the decimal value of that, 0.5714, close your brackets. It's a 55-degree angle either way. So in this case, theta is 55 degrees using cosine. Same steps as sine. Last one, here we go. What do we want? We want the angle, so we use theta as our reference angle. Opposite, theta, is side opposite, which is 12. Opposite, the 90, is the hypotenuse. Leaves us with adjacent. Oh, wait a second. Interesting. Can we use cosine here? Yeah, this is the cosine lesson. But can we use it? In this case, what do we have? We know the opposite and the hypotenuse. Those are going to be useful. We don't know the adjacent. So if we don't know the adjacent, but I know the other two, well, I'm not going to use cosine. What uses opposite and hypotenuse? Oh, sine does. So this actually would be a sine theta calculation, because those are the two sides we know. This is a great example of why you have to pay attention to the information given. We know hypotenuse. We know opposite. So that means we're going to use sine this time. Sine of theta equals opposite 12 over hypotenuse 20. Sine theta equals, if I go 12 divided by 20, it's just a terminating 0.6. So I want to now second function sine instead of cosine. Make sure you know which trig ratio to use. So 12 divided by 20, or 0.6, and we're doing sine, second function sine. 12 divided by 20, 36.8, which is a 37-degree angle. Or second function sine, 0.6, 37-degree angle either way. Theta is 37 degrees. Make sure you know which ratio to use. Your assignment for this is booklet, page 21 and 22, focusing on cosine. But then you have page as well in the booklet 23, 24. These questions require you to decide, can you use Pythagoras? Is it just two sides to find the third? Do you use sine, or do you use cosine? Great questions that you have to choose now and think a little bit of what to do. Let's take a look, page 23 really quick. Let's set one up. Page 23, question 2C. So here's where we're headed towards. What do we want to find? We want to find that side length. So the process, once again, reference angle. Well, use what you know, the 52, to find what you don't. Label your sides. Well, across from the 52 is opposite. Across from the 90 is hypotenuse. And that leaves us with the adjacent, which is attached to the reference angle. So now we have to start thinking. Step 3. We need to put all this into our trig ratio, but now we have to think. Are we using sine, or are we using cosine? Well, we want to figure out the hypotenuse, So we need to use it. The opposite is given to us, so that's helpful. The adjacent this time, it doesn't tell us how long it is. It doesn't ask for it, so adjacent doesn't help us. So if we're using the opposite to find the hypotenuse, there's your sine ratio. Sine of our reference angle, which is 52 degrees, equals opposite over hypotenuse. So this third step, trig ratio, well, now a question is just asking and giving you information. You need to do some thinking. Which trig ratio is it? So that is page 22 and 23. That is an extremely important skill set in this unit, is to be able to calculate that way. Make sure you get this assignment done and practice it, because practice makes it easier. And remember, have fun.